Hello. In this video, we're going to look at how to convert a quadratic relationship, which is in standard form, shown here, into vertex form. Vertex form allows us to pull out all sorts of information and to graph the parabola using transformations. So before we begin, let's just make sure we understand a couple definitions. A quadratic in the form y equals ax squared plus bx plus c is said to be in standard form. Whereas a quadratic relationship in the form of y equals a x minus k squared plus h is said to be in vertex form. Each of these forms have their own benefits in that they each tell us something about the relationship. Depending on what circumstances you're working in, you might use either of these forms. So it's useful to be able to convert from standard form to vertex form, as well as to go from vertex form back to standard form. So in this video, we're going to look at how to go from standard form to vertex form. And specifically, we're going to look at a case where the a term, the a coefficient value, which is located right here, is equivalent to 1. If it's not 1, there's one extra step we have to take, and we'll look at how to do that in the next video. So what we want to do in this case is this is called completing the square, partly because we want to add and subtract a term to this such that a perfect square appears in our quadratic relationship. So notice, if I take my relationship and I add something and subtract that exact same amount, that has no effect. Let me do the copier there, that's better. It has no effect on the overall relationship. So what I want to do is find a number that I can add in here such that we end up with a perfect square. So earlier this year, we explored special type of factoring cases, one of which was a perfect square. So if we have something like this, x plus d, where d is just some number squared, that's like saying x plus d times x plus d, which is then like saying x squared plus dx plus dx plus d squared, which is equal to x squared plus 2dx plus d squared. And so what we see here is this is a form of a perfect square. So what we want to do is we want to figure out what this d squared term is. And notice the b term is 2 times d. So what we can do is calculate what we sometimes call a magic number. The magic number can be calculated by taking the b term of our example and dividing it by 2 and then squaring it. So in our specific case here, the b term is 8. So I'm going to take 8, I'll divide that by 2, and then I'll square that. So 8 divided by 2 is 4, and 4 squared gives us 16. So what I'll do is I will add 16 and subtract 16. This has no net effect on the actual quadratic relationship since I'm adding and subtracting the same value. But what it does do is it makes the first 3 terms represent a perfect square. So this factors to x plus 4 all squared minus 16 minus 2. And then I can group these two like terms to give me x plus 4 squared minus 18. And now what we end up with is we end up with our relationship, which was initially in standard form, into vertex form. And that is the step-by-step process to do this. And the beautiful thing now is that from this relationship we can tell all sorts of things, such as it opens up, it has a vertex at -4, -18, It has a minimum value at -4, -18. It has an axis of symmetry of x equals -4. And I can also pull my transformation rate out of that. One last note before we go. Though this video focused on going from standard form to vertex form, it's important that you look and understand how to go from vertex form back to standard form. Again, as you become a more accomplished math student, you'll understand that different circumstances require a quadratic relationship in a different form, because each form tells us something, tells us different types of information about a relationship. I hope that helped.